Hi, my name is Jess. This is my project demonstration for my MATLAB Engineering 267 project for projectile motion function. Here is my function with outputs of the maximum height, the location of the maximum height, and the range of the projectile when you have inputs of the initial x position, initial y position, initial velocity, and the angle. The script I use to describe this code shows the equations for projectile motion here, as well as the inputs and outputs, which are given in a table, as well as the two figures that are plotted. One shows the projectile motion of the projectile, and the second one shows the different trajectories of a projectile at a range of angles. So when we run this script, it should clear out my command window and close all other plots. And then it outputs this table. Here, this table shows me the maximum height location, and the range of the projectile, which is also shown in this graph here, which the numbers correspond pretty evenly when you compare visually here. And this figure just shows the different trajectory paths at different angles at the intervals that I have specified. So to show that my function works, we can first call help to the function, and this should show us all the information that I had typed in order to develop the function, which is right here. Boundary conditions, outputs, all that good stuff. Let's clear that out. So to demonstrate the equation itself, the first input is the initial x position. We'll go with 0. Initial y position, we'll start with 0. Velocity of 10 meters per second at an angle of 45 degrees. This shows that the height that this projectile is going to reach is 2.5, just over 2.5 meters. It'll be about a little over 5 meters from the launch point when it reaches that height, and when it lands back on the ground, it's going to be a little over 10 meters away from the starting point. So what if we change that initial velocity? If we change that initial velocity, our values here in our table should change a little bit. So how about 40 meters per second? All right, there you go. That changes the maximum height that is reached, the location at which it's reached, as well as the range that it travels. If we change now just the angle instead of the velocity, so how about a 20-degree angle? Although these paths that are plotted here are all basically look the same, the scaling on these axes are different. So every projectile motion has a general increase, and then it levels out, and then it decreases in a parabolic shape. I did want to make a GUI, and I was pretty excited about it, but it is flu season, and I have found it very hard to find the time and energy to do so. So I hope that this function works for you, and I hope you have a great day. Thank you.